This format. The introduction will look regulatory bodies, water quality guidelines, the type of water in the lab, the various types of millipore water purification system. Then we'll look at a baseline study. Why are we making so much noise about the quality of water? What's the real impact? What does it mean? We'll look at the water quality and compliance, and then together we'll look at the importance of the quality of water in the laboratory. As you know, water is considered to be the biggest reagent in the laboratory. Just imagine a laboratory without water. I don't think we can do any analysis in the lab, be it dissolving any substance, washing of glassware. So because of that, we also need to understand that there are different quality of water required for specific application. So we look at the water. So we say we need water to prepare our standards for the mobile phase, for those who do HPLC, for sample preparation, to prepare our blanks, which is very critical, and then washing of glassware and rinsing of containers. We need water for that as well. Over the world, there are various regulatory bodies. So we have the American Society for Testing and Materials, who states the quality of water to be used in labs. There's a Clinical and Laboratory Standards Institute, ISO, which everyone knows. The pharma companies around use either the United States Pharmacopoeia or the European Pharmacopoeia. We also have the Food and Drugs Authority and the World Health Organization. This is to show you that no matter the industry you find yourself in, there are a set of rules that apply to your industry. So it's good to go back, look at if I'm a clinical laboratory, biomedical, what's the regulation? What does the standard say pertaining the quality of water I have to use in the lab? These are recommended guidelines. So we have 3 types of waters, and the lower grade being the type 3. We have the type 2 and the type 1. So the type 3 and type 2 are usually called pure water. And then we have the type 1, which is the ultra pure water. Now, the major contaminants we look at are ions, organic molecules, particulates, colloids, and bacteria. These are what are of interest to most laboratory. And here the guideline tells you if it's type 1, what are the limits for each parameter, be it ion, organic molecules, particulates, colloids, or bacteria. Same for type 2 and then type 1. So here we'll look at the various types of water. Type 3 being the lowest in quality. Then we have the type 2, followed by type 1, which is ultra pure. Now, MEC has classified them. Usually you have the type 3 being the Rios water purification system, the type 2 being the Elix, and then the type 1 being the Milicu. That's the ultra pure water. Type 1 is typically used for glassware rinsing, heating baths, feed of type 1. So some of the type 1 systems do not take the water directly from the tap, but rather would need water from already treated water to feed. So we have 2 types. So systems that take water directly from the tap and then treat them, or systems that require pre-treated water. So in the case of type 3 can also feed a system that requires pre-treated water. Then we look at type 2, buffer, pH solution, anything you can think of in the lab, weather chambers feed, autoclave filling, and then also this can feed the type 1 water system. Now, the ultra pure water is usually for very critical applications, so gas chromatography, high performance liquid chromatography, atomic absorption, ICP-MS, ICP, GC, GCMS, all those. Mammalian cell culture, IVF, and then molecular biology. And also for clinical analysis in the medical institution. So when you have your sample, your test done, the best quality of water has to be used. Now we look at the most common type of purification of water in the laboratory, which is distillation. What are the disadvantages? Anyone who has used distillation can testify to the amount of heat generated when the water is being treated. So you have about 2 kilowatts of energy, which is needed to distill about 2 liters of water. Then, once you have the water heated, you need to condense it. So you need about 20 to 30 liters of water to cool the vapor and then produce about 2 liters of distilled water. So we can imagine the amount of water that goes to the drain just to produce a small volume of water. And there's a lot of challenge if you have hard water, because then you would have your distillation plant looking like this, and no one in the lab wants to clean this. You will require acids to clean them. And then it makes the glass very slippery and could easily break or cause injury to the person cleaning. Another disadvantage of the distillation is you are not sure of the quality. There's no display, there's no monitoring. So you distill water, you collect, you don't know the quality of the water. The water is held in closed containers. So what it means is you've spent a lot of energy heating your water, you've condensed it here, you've cooled it, and you collect it usually in a gallon just by the bench. And those gallons are usually left half open so that the tube can go in and then let the water drip. The water here is usually warm, which forms a perfect environment for bacterial growth. So as you can see, you spend a lot of time and energy trying to produce very good water only to expose it to contamination at the end of the day. Is it worth it? Lab water, any water you use in the laboratory is very, very important. That determines the result. So if you have errors in the end, if you have bad results in the end and you are troubleshooting, where do you go back to? Is it your glassware that wasn't properly cleaned, or is it the water you use that wasn't of the best quality? Here is a comparison between the distillation, so what we just spoke about, the no monitoring, no display, you can't see, but here with the MEC water purification system, you have a display, it gives you the resistivity or conductivity. You can have the TOC value as well, and then the temperature. And these usually give you a low running cost compared to this, where you'd have to use about 2 kilowatts of energy to produce 2 liters of water, and also between 20 to 30 liters to condense that same water. So with these systems, as you see in A, B, and C, you spend less energy producing the water, less water in producing water, so you have less waste. Now we'll look at the 3 types we spoke about. So the various systems that will produce that. So this is the new generation of the MilliQ range, which is a MilliQ IQ. Those of you who have the MilliQ Integral, you can speak to us. You can leave your information in the message, and then we can have a look at how to replace those systems with the new technology for you. Then we have the MilliQ Direct. So the MilliQ Direct, as the name suggests, takes the water directly from the tap and then gives you ultra pure water. And then you have another MilliQ Direct, also a smaller volume. So these are designed in such a way that every lab can have the best system for their application. The last system here comes with a 6-liter internal reservoir. So for research laboratory or labs that do not need a lot of water, this is the ideal solution. This can also be connected to a bigger reservoir, say a 30-liter, 60-liter, or 100-liter reservoir. Then you have systems that produce the type 2, and depending on the volume also, and then the type 1. They look alike, but the step in the production is different. Those in the clinical market, so you have the analyzer feed system. These are the AFS that will produce the clinical reagent water needed for immunochemistry, hematology, microbiology, anything you do in the clinical laboratory setup. Now, why are we putting so much emphasis on the quality of the water? Here, we'll have a look at an analysis that was carried out with double distilled water being the green line, HPLC bottled water. Then you have molecule water before UV treatment, and then molecule water at the point of use. You realize that this is just water that was injected, and you have a chromatogram at 230 nanometers for the 4 different types of water. You realize that for the double distilled water, you have a very high baseline. What this means is if you have an analyte of interest, which appears, let's say, at 15 minutes when this peak appears, how do you determine which analyte you are looking for? Ideally, your baseline should be as close to 0 as possible, because water should be hydrogen and oxygen, H2O, just that, nothing else that would give you an absorbance of 0.8. So we look at water from double distilled water using an LCMS, and then we can see all the peaks in the baseline here. Then we look at B, HPLC grade water, and this is bottled water. We have these peaks as well. Then we look at the C, which is molecule water before UV photooxidation, gives you this. And then the last one, which is the D, we have the molecule water, which is the ultra pure after photooxidation, so with UV. You see that this is almost flat. This is the best you can use for your analysis. Then you are sure that whatever peaks comes here is actually the analyte of interest. Water quality compliance, various organizations, be it the European Pharmacopoeia, USP, the Japanese Pharmacopoeia, Chinese Pharmacopoeia, all determine or give guidance as to the type of water you required in your lab. So purified water, and then especially for the biomedical lab, Clinical and Laboratory Standards Institute, CLS-SI, would recommend the clinical laboratory reagent water. So in conclusion, as we've seen through the slides, it's very important to have the right type of water for the right analysis. That's very important. So if it's washing of glassware, you use the right type of water. If it's the preparation of your media, the right type of water. If it's a blank you are reading in the UV spectrophotometer, you need the right type of water. If you are doing a critical application, HPLC, GC, GCMS, you also need the right type of water. And remember, water is the biggest reagent used in the laboratory, so we need to pay attention to that. Our aim is to help you, our partners, to define the right type of water that is suitable for your application. So if you send us information or you send us a request, we may ask you a few questions. What type of analysis do you do? How much water do you require per day? How is your water usage spread within the day? That helps us recommend the best system for your application. Then MEC has three ranges. So the type 1 being the ultra pure, type 2 being the pure water, and type 3 being the lowest grade of water. We are committed in making a difference in the quality of the life and the environment. That's what we work towards at Cleanearth Scientific. you can contact us on the numbers here, or you can send an email to info@cleanearthsci.com. We'll get in touch with you. We'll take your questions, and thank you for your attention.